Thanks, Jeff.
Sure.
Good. I'm glad I can be heard. Now let me share the screen quickly. Sorry, I have two to choose from. It looks like this is the one here. Let's make sure it's right when it pops up. Yes, it looks like that's correct. Yeah, thanks. I'm going to time this so that we finish and allow a little time for questions. There's time for 3 case studies. I think these were done as commissioned by SCE. You can see their logo there. This is the 6th book, yes, the 6th book of case studies that the utilities of California have commissioned over the last 6 years. There's been a shift from net zero energy design, good case studies of all those building types in California, to zero carbon, and now we're designing for zero carbon, and more discussion of that. And embodied carbon is the first time it appears is in this book. I'm going to make available these books are all free can be downloaded as a PDF, and so it's a great service to professionals and clients in California. So either you advance. Sorry, my mouse is misbehaving. Let me. I got a little more control over it now. Let me just finish. I'm going to put a link to the where you can get the other book in case you're interested. And I will mention that we're working on the 7th book right now. It's focusing on multifamily housing, all electric multifamily housing in California. And so that'll be very timely and very interesting. But let's plow ahead with this. 3 case study non-residential buildings in California and 3 typical building types. So there's a spec office building, quite a common type, public middle school, public school district, and a college classroom, which is a renovation project. So the first 2 are going to be new buildings, and the last one is going to be a renovation. I'll talk about each case study according to this format. So you'll see just the project background, then the zero carbon design strategies. Luckily for us and the world, I guess, in 2045, California has targeted a clean power for all its utilities, and we will be carbon-free power supplied by the utilities. So that's 22 years from now, and this is the way we're going to get there. And the next topic will be renewable energy sources that are part of these projects. Then we like to include an energy analysis. Buildings usually have modeling done, but they don't always. But a little anticipation of how they should perform, how much carbon goes into the construction of these buildings, and then the actual energy performance over the course of 1 year. That was very important for zero energy buildings. It's equally important to make sure that the design achieves its goals. And then post-occupancy evaluations. We're going to talk a little bit about lessons learned in the process. These are all cutting-edge building designs, so there's always something that you can do better. So the first one is the spec office building. This one is in San Diego. And you can see it occupies a corner. The client was a Langford and Associates, a developer, and the joint venture development team with Langford and the architectural and engineering design team won a competition to develop this 6-block area. And this particular building is one of the blocks. And you'll see in a minute a diagram, a view. And the project goals, one of the reasons I think that they were successful in the design, besides the quality of design, was the project goals were very ambitious, and they showed that they could had a path to get there. Zero carbon operating and highly energy efficient. So the building program is 60,000 square feet, 10,000 of which is ground level retail. And as I mentioned, it's located in San Diego. So the site vicinity, this is a part of San Diego that it was underdeveloped for many years, had a lot of low-rise manufacturing and artist studios, and it got to be known as the Maker's Quarter, and that it takes its name after this. The property owner was the Navarro family, and they continue to own the land, and the buildings are all being built by developers, and it's done by a ground lease. It turns out that the zero carbon goals of the project helped them get financing for the ground lease situation, which is, as I understand it, somewhat difficult to get financing, where the owner retains the property ownership and leases out the project above. They did one housing project first, and then the Block D office building, the subject of this case study, was the second project. So the building envelope, first category. It turns out the San Diego Planning Code does not count outdoor balconies as assignable space. So the designers developed the idea of an indoor-outdoor tenant space with natural ventilation, and they included it in the suite, so that a tenant would get all the space available. It was usable. As you know, San Diego has one of the best climates anywhere. It's kind of ideal. So it lent itself to the solution of daylighting, natural ventilation, and occupying areas outside. So they had to design a control system to respond to that. And you'll notice the plan on the left, there are these dotted areas. These are actually garage doors. In the picture on the right, you see one. They were a feature of the design as part of ventilation and access to the balcony space. And so the control system makes sure that the heating and cooling system does not operate if the garage door is open or a window is open. Also, during the wintertime, it makes sure that the windows are closed, then it allows the heat to come on. So the tenants are informed about all of this in their leases, about how to operate the spaces, because it's very unusual, not a typical space, and they had to have a certain amount of education. It turns out that they had no problem getting tenants for this building. It created a lot of interest for its sustainability operation and design. Let me go to the next slide. The sun control is done. The building, you may have noticed, faced the west on the long side. So they designed sunscreens which are actually movable. So when tenants are out using part of the outdoor space, they can move the sunscreens easily into place to mitigate direct sun getting on their work surfaces. And the south end of the building has these blinds which are adjustable, automatically adjustable to the position of the sun. So it provides full shade on the glass at all times automatically. And the distance between the blades adjusts as well as the tilt of the blades. So it's a fairly sophisticated sun control system for the envelope. You can see this, the day lighting. This they have overridden here and letting sunlight in, but this is a space obviously not occupied at this time, but it gives you an idea of what this space is like. And this is the control system at work, a diagram. As it turns out, because of the climate and the way that the building operates, the mechanical cooling is rarely needed. For the entire building, there's a single heat pump with multiple zone fan coil units connected with variable VRF lines, which is variable refrigerant flow, to each of the fan coil units on the floors. And each floor has its own, this is the language of mechanical engineers well understand it. Each floor has its own GOAS unit that is dedicated outdoor air supply. And it's an energy recovery heat exchanger for fresh air and exhaust airflow. So there's an energy efficiency that results from this design. There is also the demand control ventilation that controls the amount of fresh air based on the measured CO2 concentrations. And it takes in more air if more CO2 is detected inside the tenant space. Here's an all-electric kitchen, no gas at all, no gas service to this building. Nothing was brought in from the street, even though gas is out there. Even to the retail spaces on the first floor of it, there's a cafe. They're using all-electric cooking facilities. The PV array to provide energy was a challenge, and to get it again, so it's elevated above the mechanical equipment. You can see here a diagram. There are also bifacial solar panels which extend over the edge of the parapet, and they get solar energy from both sides of the panel. It's a nice idea, and it works. You can see what it looks like in this slide. So they're collecting energy both above and below. You can see that they're elevated on a trellis-like structure, and they got the maximum amount of solar PV. They did modeling for the energy. You can see the energy modeled at 29.2. In all three of these case studies, a peculiar thing happened in 2020. We had something called a pandemic, and the buildings were either minimally occupied or not occupied and so on. And there was an effect here. In this case, the tenants started to show up in the end of 2019. And so the data that was used here in the study was only occupied for the second half of the year. So the measured EUI is low. It'll be more than that when they return to normal occupation, which they're just getting into now. And so we'll know better in the future how the model compares with the measured. But it looks good. And here's an example. This curve, the curve to look at here, the orange one which is the energy production of the PV system, and the energy use of the common area, which is the solid black line. So you see the energy production is more than the energy used in the common area. But once the tenants move in, those PV panels are not going to be enough to provide power for the building this large. So it's just the common areas that tenants are using electricity from the grid. And this graph shows that basically it's, when you consider the whole building with the tenant spaces, it's net negative, but it is in fact net positive. More energy is produced than used when it's only the common area. And so post-occupancy, the goals were achieved. They got Z&E for the common areas. The financial goals were achieved. They got a tenant in there right away. And developers like that. There was no period of non-occupancy. The commissioning challenges were met, and they seem to be working very well. And there was not an embodied carbon assessment. This was before the tools that are available now. They were not very easy to find in these days, or weren't very good. I'm seeing we're at 20 minutes in, and so I'm going to go right to the next project. A public middle school. You can see a picture of it here. This is in San Francisco. So it's an urban school, San Francisco Unified School District. The project goes again, zero carbon, and they wanted to do zero in energy performance for the old electric building. The building is in addition, it's a middle school added to an existing elementary school. So there's 12,000 square feet of classrooms and a gym, and it's 2 stories. Here you see the site. It's in the Marina District of San Francisco, for those of you who know that city. It's kind of urban, but low-rise built. And here we have a site plan. The existing building was 1920s to 1930s style classic public school. And when they needed a middle school grades there, they got all these bungalows in, which are shown in the site plan. They have since been removed, I believe. And they put the new building here on the south part of the site. And the building envelope. So there you see a wall section on the right. Rigid insulation is applied over metal studs to prevent thermal bridging, a very good practice. There are manually operated windows for natural ventilation. You can see that they're quite large for daylighting. This is all classic design strategies and not expensive at all. There's some sun shading on the south side of the classroom wing, and the gym has a large cowl wall array and has skylights in the ceiling. They had to be careful so that they didn't interfere with the game playing on the floor below. So it's not glare. That's one of the reasons they chose the cowl wall. And there are occupancy sensors, so no lights come on when no one's in the space, and so forth. All currently required by Title 24. Heating system, there was high efficiency ground mounted BRF heat pump and fan cooling units that's similar to the office building, and a roof mounted VAV heat pump package for the gym. They went with standard electric resistant hot water at this time. I wonder now if they designed the building now, they would just go with the heat pump. They're much more energy efficient and cost effective. So you can see here in the roof plan that they had issues with the neighbors. There was a little bit of NIMBYism that went on. They didn't want to see the solar panels or the roof ceiling equipment from the street. So they were required to keep a standard roof on the part of the building that was on the south side of the site. And so they were squeezed for the amount of solar panels they could put on the building, and to get it supporting the loads, the predicted loads of the building below. So there are 145 panels. They're not yet installed. They are being installed this year. A third-party PPA, meaning that the third party will install them, and the school district will pay that company, just like their utility, for the panels, the power they get from the panels. And there was a PV model, a production was modeled. And you can see it was 13.4, and it is also the model amount for the building. So the numbers seem to say that they're going to be, in fact, net zero. But again, this is the graph in the 2019-2020 school year, and we know what happened in the 2020 school year at the end there. we had the schools basically shutting down for these last months. The actual energy performance, the additional problem, sometimes you get this with a school, was that they are metered, both the existing building, that was the 1930 existing building, and the new building, we're all on the same meter. So all of this is an analysis of the average amount of energy used and factored into the floor areas of the two buildings. So it's not an accurate electric energy use number. It's a kind of mathematical calculation. And as I say, the pandemic occurred and so everybody went home, and they're just coming back now. And so we really don't have good data yet, and the PV system is just being put in place. So unfortunately, these graphs are the best we could do with it. They're not the real calculation. And I would say don't pay any attention to this one because it's showing it to be negative. We'll know in the year 2022 to 2023, the actual data, because they have separated the metering of the new building from the old building, and they have the PV system up and running, and the kids are going back to school. So we'll know in a year how close it is to the modeling and so on. But we can say that it looks like the carbon goals are being achieved. They did not do, this is another example, they did not do an embodied carbon assessment, again, because it was designed before analytical tools were available and readily used. I will say that they did a study did a pre-building study. This project was the first building built after the study was done, and they set design standards for the city, which included zero carbon goals and zero net energy performance goals. And this project was built according to those design standards. So it will be a test not only of this one building, but of the actual design standards for the school district going forward, and all new buildings or all renovations for that matter will meet these higher requirements. Let's get to the last project, the renovation project, which is very interesting from a lot of points of view.
Excuse me, Edward, real quick. This is Christine from AIA Long Beach South Bay. Just want to remind everyone that the attendance link is in the chat. You will not get learning units unless you fill out that form. There's a link in the chat. The PDFs are also accessible that way. And for those of you who are on the program with your cell phones, you're going to have to find that link on your phone Zoom app in order to get units, because we don't know who you are, because your name, you either just have your first name or your phone number. So, okay, I'll turn it back to you, Edward. Thank you. Sorry for the interruption. Okay,
no problem. It made me think. I'm going to see if we can get links to the 6 case study books I mentioned at the beginning. Get a link into the chats in case anybody wants to download those other books, and the future book on all electric multifamily housing, which I think will be of great interest. So I'll try to get that in the chat at the end of the presentation. So anyway, this is a very interesting project. Some of you may know it. It's in the Claremont colleges. So it's a renovation. I'll go back to this nice photograph. It's an old building that was built in 1931, and I'll give a little bit of the history of this building. It's on a commons site for all of the Claremont colleges. It was a field station at the time in 1930, and they put this building on, built the building there. And then they renovated it for a classroom office building. They chose renovation rather than build a new building. And I'll show you, these guys went through an embodied carbon assessment and made an obvious conclusion that they should renovate this building. The building itself used to be a student infirmary that they built away from the campus. They built it and they want to use it as a college classroom building of all types, programs. It's at the Columbus Pitzer College, one of the 7 Claremont colleges. It's a, they wanted a stretch goal of LEED Platinum, and they wanted zero net energy certification from ILTI. But zero carbon is really, all electric is really good, the goal. It's 14,000 square feet, science labs, studio, collaborative workstations, a general use college classroom office building. And it's in Claremont, actually in Claremont. And here's the picture of the site. You can see it's on the edge of what looks like an open area, and it's right next door to a suburban development. They built right up to the boundaries of the, oops, sorry, my mouse is acting up again. Okay, sorry. So there it is in the corner. You can get at it by driving a car through these suburban streets and getting to the location. So in 2015, the college did a feasibility study of locating, they called it a conservancy. There's a lot of classes that are given there that are about sustainable development or design in all aspects of life, I guess. And they wanted to use this existing building, which was in great disrepair. It'd been abandoned in 1970, as it turned out. This feasibility study included the building program, cost estimate, energy modeling, and the embodied carbon assessment. The design and planning team was selected, the architects were Carrie Johnson in LA, and the mechanical engineers were Integral Group in Los Angeles. The feasibility study led to the decision to renovate the building, and it would be that renovation would be led by the same guys who did the study, and they would become the planning and design team. And the building was occupied in December of 2017, so pre-pandemic. The irony is that it was initially built as an infirmary and a quarantine facility in 1931. It was only 10 years after the pandemic of 1918 and 1921, which was kept under wraps compared to the current pandemic. So they wanted to, when they made a student infirmary, they wanted to get it away from the campus and isolate the students who would get ill. They had a lot of foreign students coming in, and they had the attitude that we didn't know what kind of disease they might have brought in with them, and so we want to isolate them. So they built this facility in 1931. Then, as I say, it was closed in the 1970s. Was getting run down. It wasn't being used as an infirmary anymore. But the local city, Claremont, wouldn't let it be demolished the way the college wanted, because it was considered historic at that point. So it was left alone and gradually decayed. And there were animals and so forth living in it when the architects were doing the feasibility study. So I want to just quickly touch on this embodied carbon study that they did. They used, there's several software packages you can, that's not the subject of this particular talk, but you can get one, you can get 2 or 3 different kinds of analyses of embodied carbon. This one, the one that was used is called one-click LCA, or life cycle assessment. And it produces, uses the data output from a Revit model, so it's kind of easy to plug in to your project and get the information out. And the architects got Integral Group Consulting got the analysis done. and you can see in the body carbon breakdown of the renovation that the biggest bulk of energy, if they do the renovation of the project, would be pouring concrete and basically the structure. There's a small amount, I will note, that is given over to the PV system. And then if you compare it to the amount of embodied energy in building a new building, you can see the big element here is the purple, the concrete structure, and that's where all of the embodied carbon is being dumped. There's a lot, it turns out, in the, let me go back, sorry. Yeah, external walls and facade is the other big item. That's the dark brown right here. There's a sliver, I will say, that is shown here, but you can hardly see it in the new building. But the PV system has a little bit of embodied carbon as well. It usually takes about a year to of production by the PV panel to pay off the energy carbon used to build the panel itself. So it's a small amount compared to the life of the building, but it's a small factor. Everything has some carbon costs right now at this time. So they did the embodied carbon analysis, and they felt that this showed we ought to renovate the building, especially since the program fit inside the existing building, with some modifications, and I'll say what they are in a minute. So here it is, the program fit into the old building. And what they did also is use the basement, which used to be just storage and mechanical equipment, to make a little bit of space down there as well. And let me see, let me change itself. Yeah, so next slide is the wall section. The window frames are original, but they replaced all the glass with single pane, and they replaced it with double pane units. They insulated the, you can see what they put on that by applying studs to the inside of the concrete walls. It was bare concrete originally, and they insulated walls. They put insulation in the roof. They put a radiant barrier up there, and they went ahead and insulated the joist floors. So complete retrofit that way. So there were skylights in the original building, but they were later removed and covered over. And so by adding back skylights, they saw this as part of the historic restoration. And they wanted to, they did a daylight analysis, and they selected option 2. You can see that there isn't a whole lot of skylighting, but there was enough here in option 2. They got better light quality in this. The option 3 produced a little too much light, a lot of direct sun and so on getting in there, and it was considered to be glarier. So they went with option 2 for daylighting the major spaces. This is what it looks like in there. So lots of windows, and because it was initially a field hospital, essentially, there was a lot of windows for lighting and ventilation. That was considered to be a healthy thing, and you can see it here in the photograph. All the windows are originally they opened like that, and the doors as well. They got lots of fresh air, and as I say, they replaced only the glass. And the skylights themselves open, so they get the natural airflow in through the windows on the side and out through the top, through the roof. So there's lots of good natural ventilation. They also were able to use this buoyancy effect of the skylights. You open the skylights at night and let the cool night air flow in through the building, pre-cooling the building, and then they button it up during the daytime when it gets warmer. So this is called night flush operation. It's a good design strategy for this climate. It's called a mixed mode system by using this kind of night flush. And the solar panels, because it was a historic building, they did not want to put the panels on the roof of the existing building. So they built outdoor classrooms that have canopies, and it's on these canopies that they put the solar PV. And it also took care of the little bit of program that they could not fit in the existing building. They actually hold classes in the outdoor area. Fortunately, it's a good, warm California, now currently dry, good climate doing something like that. Here is the comparison of the modeled energy use and the measured energy use. Again, 2018, 2019, pre-pandemic, they started to use the classroom more heavily in December and January. So again, even though the measured EUI is lower, it doesn't quite reflect the use that they're going to get now that they're going back to classes and using the facility with a full load of students in classes. But it looks good and looks promising. And here you see that they produce a lot more energy than was used in the building, except in those last 2 months where they had a full student, lots of full classrooms and meetings at night and so on. They were using more electricity, and during this year, it was very net positive because they were just building up the use of the building, and they had the solar panels were operating at full power, so they got net positivity in that first year. Pandemic years are not being counted, and now they're getting the full load and experience. So we'll hear about that, how they're doing in the future. So I just want to say, I'm wrapping up here on time. Well, the project goals achieved for this renovation project, they got their ILPI Z&E certification, and they got LEED Platinum certification. They minimized embodied carbon by doing the analysis, and they got the program into the space. So yes, I guess they did achieve all of the project goals. The mixed mode cooling system, yeah, this is the same. It's similar to the spec office building. The users have to be educated as to how to use the building. They have a fairly sophisticated way it has to be operated. If you're feeling cold and you're wondering why, well, close the windows and then the heater will come on. Otherwise, it's going to shut off. It's going to stay shut off. So the users have to be told this or handed out flyers when they start taking classes there. So that's something to always keep in mind. Yet, as true as it is for the maintenance staff as it is for the casual student or faculty user, everybody has to know how these buildings operate. And the embodied carbon assessment, they're very proud of the fact that they did it and they made a right decision as a result of that. So this is an overwhelming success, this particular project. And with that, I guess we can take questions for a few minutes and hope we can answer it. So Jeff or Linda, you'll have to tell me what to do, or?
Yes, I was just checking, and I see we do have some questions in the chat. Are you able to get to those, Edward?
Yes, I am. Okay. Oh, Dave has a comment. For those on the phone, I can't read the chat readily. It says, I assume DI is Dave Bittner, some Southern California Edison. Solar thermal can complicate a heat pump system because heat pumps don't work well with high input water temperature. You need a standalone buffer tank to make those work. I'm sorry, Dave. I guess you maybe answered somebody's question. No?
Yeah, that's right. There was a question in the chat about potential for solar thermal in those cases. There was, some discussion about the electric resistance versus heat pump, and the addition of solar thermal, perhaps. So, with the high efficiencies of heat pump, it's arguably better in many cases to just stay with the PV system. It means you have one system instead of two.
Right.
It's a bit more maintenance friendly over time. And then you just drive that highly efficient, 3 to 4 times as efficient as a traditional combustion type water heater system through the energy produced by the PV. And then, the PV is just serving all the electric needs of the building.
Right. Okay, good. Is there any, you've probably been looking at the questions popping up. Do you want to take the questions?
There was a question it looked like from Nick Brown about the tools used for doing the embodied carbon analysis. I can't recall if the project team provided that level of detail as to what their analysis looked like and what tools they used to carry that out.
Yes, the project team did, and I think it was I mentioned in the talk, it was called, the software is called One Click LCA, and it's you can buy it as a added onto a standard Revit program. So that's what the team used, and they produce all those diagrams. Oh, you got this link to the case study books. Good, you got it in the chat. Thanks for doing that.
Yeah, hopefully people find those all useful. I'd also note that in addition to the featured case studies in the most recent volume, there were summaries of, I think, 8 additional projects that were all electric non-residential buildings that there's some information and highlights, but not quite the same deep dive we did on the 5 projects. And there's also reference back to the projects in previous volumes that were all electric,
Right.
to highlight those as well. So it's the 5 projects in detail, but it's also kind of like pointing you back to additional projects that were previously highlighted, as well as some others. And we're gonna have a lot more projects to look at in the next volume, specifically focusing on multifamily, which Ed had mentioned is currently in the works.
Right. We hope to get it out available to the public in, I would say, January. The schedule is January 2023. So I see no more questions. Want to take it from here, Jeff? Oh, stop sharing.
Yeah, I mean, at that point, I would say if anybody wants, they can come off mute if you'd like to go ahead and ask a question. If not, then we're giving you a few minutes back into your day for your noon hour. Yeah, I see some thanks in there coming through on the chat. So at that point, thank you everybody for attending today's ZNCD program. As mentioned earlier, there are many opportunities for you to get these credits, particularly if you have, say, a January or a February birthday coming up in 2023, which is when you'd have to report the credits. You can always reach out to Christine or me. You can also go to AIACalifornia.org and you will see their courses listed there. Also, we are receiving an e-blast of courses. They have at least one a month so that you can achieve those 5 learning units. And don't forget, you need your 5 ADAs as well. Thank you so much. Thank you, Edward. Great presentation. Thank you, Dave. As always, it's a pleasure to partner with SCE. And at this point, I will go ahead and close the program. Bye, everybody.